So in this video, I'm going to continue a sequence for topic method of difference, but I will extend from linear case to non-linear case. So before we apply method of difference for linear sequence, so basically in the form an plus b, that's basically arithmetic sequence. And today we're going to extend these methods and we'll try to apply it to quadratic sequence and a cubic one. All right, let's get started. Here we go. So let's say, as in the previous case, I'll take a certain sequence. For example, I like this one, say n squared plus 2n plus 3. So let's pretend that for now we know the formula and we're just going backward. We want to generate several terms. Okay, so that's counting number and that's un terms. So let's plug numbers 1, 2, 3, 4. Okay, I think it's enough. And let's plug the values into the formula. So I'll get the following. When you put 1, so you'll get 1 plus 2 plus 3, so you'll get 6, right? So you'll get 6. Okay, so the next one, 2, you'll have n squared, so it's 4. So let's calculate. So 4 plus 4 and plus 3. All right, so you'll get 11 here. And let's plug one more. So 3, you'll get 9 plus 6 plus 3. So you'll get 18. 18 here. Okay, so let's calculate for n squared 16 plus 8 and plus 3. All right, so we'll get 16 plus 11, or it will be 27. All right, so we'll get 27. That's enough. Okay, so we generated several terms of this sequence. And now let's pretend that we have no idea about the formula. So pretend that we don't know. Okay, so pretend that we don't know. We want to figure out the way how un depends from n. According to this sequence, and this is quadratic one, it depends in the quadratic way. So generally we can say that in general formula that will be a n squared and b n and c. It's very similar again to the function, to quadratic function, where you have x squared plus bx plus c, right? So anyway, this is quadratic formula or quadratic dependency, un's term from n. All right, so our goal is to figure out again coefficients. All right, how do you think how many equations you need to set up in order to get those coefficients? Yeah, you're right. You need to set up 3 equations because 3 variables. But it seems to me that to resolve a system of 3 equations, it might be tricky. Many of you guys probably hope that I'll give you maybe a more easy way how to do that. And actually there is the way that's called method of difference, no doubts, but for quadratic sequence. All right, let's see how it works here. Okay, we have several terms, we know the values, and we'll try to figure out the difference between them. All right, so let's define the difference. And just transfer this part a little below. Okay, so that we have enough space. Okay, now we trying to figure out the difference between elements. So hopefully you understand that the first difference is going to be changing. Let's see, the first difference is 5. So if you move next, there is 7, and if you move next, so there is 9. But obviously, so it's not constant. You can say it's not constant. However, if you attempt to figure out the second difference between differences, so you'll get 2, so obviously the next one is going to be 2, and we be able to calculate the next term. Okay, but we understand that the second difference is not changing. All right, so what it means? It means that if we plug values for n into general formula that we established, we will have several equations, right? As in the previous case. Okay, so let's try to do and just plug several values instead of n. So that's n, and we are going to take 1, so 2, 3, and 4 probably. Okay, so we need a bit more space here. All right, so let's plug n, and let's see how terms will look like. If we plug 1, so we will have a plus b plus c. Okay, so I'll just shift a little bit because we need more space. So that's 2, that's 3, and this, let's say 4. Okay, now let's plug 2. If we plug 2, we'll have, so instead of n, 2 squared, right? So that we'll have 2 squared, means 4a, then 2b, and then c. All right, and let's plug in instead of n, so instead of n, let's plug 3. We'll get 9a plus 3b and plus c. Okay, we're not going to do with 4. And let's see now, let's take the difference between adjacent terms. It's going to be the first difference. And actually what we need to do, so difference by definition is the next term, right? Minus, so I'll write more properly. So we need to take the next term, un, and subtract the previous one, an minus 1, all right? So un minus un previous. So basically in this case, it's u2, it's u1, and this u3. So what we need to do, we need to figure out the difference. All right, let's do it in letter, using letters. So 4a minus a is 3a. So 2b minus b is b, and c will be cancelled. We'll do the same for u3 and u2. All right, so we'll get 5a, so plus b, and c will be cancelled again. Okay, so we calculated the first difference, and we established that it's 3a plus b. All right, so, and you know that the first difference, we have specific values for that. So the first difference, 5, as difference between the second and first term, and 7 here. So we can write successfully that this is 5 and this is 7. All right, as you notice, we again arrived to 2 equations, right? And we can establish the system of equations or simultaneous equations, but we go using the method of difference. So for students who wants to apply methods of simultaneous equations, can do that, and you guys be easily calculate A and B values. Okay, so the second difference is the difference between differences. So the second difference is just basically 5a plus b minus 3a plus b. So, and we will left with 2a, and b will be cancelled. But on the right side, there should be 7 minus 5, that will give us 2. All right, let's see what we arrived to. We should arrive to the second difference, of course, it's 2. So, and the result is 2. All right, so it turns out to be that 2a equals 2. So that's the first formula where you can easily find a. So generally, because this is the second difference, you can set up the formula second difference over 2. So someone who likes like just remembering the formula and have good memory can just memorize. But for those who are mostly caring about understanding, just try consequently or consistently apply the difference approach, all right? And you'll find your values with no problems, trust me. So for example, as for me, I don't like remember those like huge formulas, because you understand that for like several topics you need to remember at least like, let's say, at least 5 formula for that. And it's craziness if you just go through all the topics in GCSE, and if you go to like high levels like 2IB to A level, it's not possible to recognize everything and to memorize that. You just crash your brains. So stop doing that and try to understand how it works, instead of like just crashing your brains and trying to keep all the formula in your heads. So your head as hard disk, as hard drive, has like limited capacity, so limited memory. And the more formula in your head, I think the slower you're thinking. So that's why you need to stop yourself and just be concentrated, be focused on understanding. That will definitely help you in your life. Okay, not only in maths, in any subjects. Okay, so we figure out that, okay, A is delta 2, the second difference over 2, but in our case, A is 1. Okay, we established the value for A. What we can do, we need to find B, of course. So B, we just plug the formula back, value A equals 1, and we'll see that B is actually 5 minus 3, so it's 2. All right, we established value for B as well. And we again lift it up back to very first element of our sequence. So A plus B plus C is actually U1. So the value for U1 you can pick up from your first term, 6. So that's why it equals to 6. And we know that, so B is 2, A is 1, and we can plug both values here in the formula. So, and C is basically 3, all right? So we establish all values for all coefficients, 1, 2, and 3. Let's go back and see how that was the original formula. It looks exactly the same, so we figure out A equals 1, so B equals 2, and C equals 3. And now you can just compare with coefficients. So 2 here, 3 here. So don't be confused, there is no 0, otherwise this term will be skipped or messed up. So in this case it's 1, so imaginary 1 times, right, n squared. So that's why A is 1. Alright, so one more time to recap what we did. One more time to recap this logic. So we had sequence 6, 11, 18, 27. We established the first difference. So it's difference between elements. We also established difference between difference. It's second difference. And we find out that it's constant. This is constant. So that's why your formula should look like quadratic sequence. All right. So that's why we are looking in this form exactly. For example, if you found out that the second difference is not constant, you need to keep going your process until you reach like a certain level, difference is not changing. So in this case, it's constant on the second level, so that's why it will explain the fact that the maximum power is 2. If it were like not constant, pretend it's not constant, it's like the third difference. You need to find the third difference, and third difference is constant. You'll have a cubic equation, right? Or cubic formula for the sequence. Okay, so one more time. We looking for coefficient A, B, and C. What we're doing, as for arithmetic sequence, we set up counting numbers up to 3. Yes, we don't, yeah, we didn't use 4, so that's enough to use all three counting numbers. So it means 3 terms, u1, u2, and u3, and we just plug in, instead of n, different values from our natural numbers. All right, so we're just going back and we established values for u1, for u2, for u3. Then we moved to the first difference, and we established that the first difference is just the difference between u2 and u1. And we actually use the formula and subtract from u2 u1. We arrive to 3a plus b and equals 5. Why it equals 5? We know that the first difference is 5. All right. We do the same for second and the third element. We subtract them, and we establish that it's 5a plus b equals 7. Why 7? Again, because this is 7. Okay, and we trying to find out the difference between difference. So basically, it's the second difference. And if we subtract 5a plus b and 3a plus b, we're left with 2a. And the result is going to be the second difference. Okay, one more time. So the second difference divided by 2 is actually leading coefficient. If you're good at memorizing, so you can memorize this fact, and using that as reference, just go back here. But anyway, I don't think, and it's probably less likely that you can memorize all those formula. It's craziness, so don't do that. Always try just to apply this logic consistently, and you'll do really fast with more experience. So, okay, you found out that A is 1. So let's go to B. We plug into this equation. So 5 equals 3a plus b. We plug A equals 1. And we figure out that B equals 2. All right. We know A and B. Now we can find C. So from the very top equation. As you understand, so we reach the bottom line, and then we just going back cascading, right? We go in cascading manner, trying to, like in chain, we're trying to figure out all other coefficients. Okay, successfully found out A, B, and C. That's the method of difference. So no problem to apply this method for a cubic equation. So I'll try to, let's say, which sequence to take. It's interesting. Okay, so maybe I'll show you in general, in general sequence. For example, let's say we have un cubic formula. You might be given exactly that's cubic without like given any sequence elements, sequence terms. Okay, what we can do, we can create a table in a similar manner. So 1, 2, 3, and obviously we need the fourth element because that's cubic 1. Alright, so there are 4 counting numbers, and we're going to plug into the formula un. Alright, so here we'll have, when we plug in, whenever your n stays right here, so we will have a plus b plus c plus d, right? So we'll get all those numbers, all those coefficients. So our goal is to find them. So find a, find b, find c, and d. All right, looks like we need to have like 4 equations. Or in terms of difference, we need to go up to third difference. All right, let's plug 2. So we'll get 8a, so plus 4b, plus 2c, and plus d. All right, when we plug 3 here, we'll get the following. So looks like 27a plus 9b plus 3c. Yeah, you see, it's more difficult in terms of like pretty, large expressions. So 9b and so 3c and plus d. All right, and let's do for fourths. So for fourths, the layout is here. So we plug n equals 4, and it will be something like 64a plus 16b plus 4c and finally plus d. All right, so what we can do now, we understand that we need to figure out the first difference, the second difference, and the third difference. Yeah, that's exactly what we want to do. So the first difference is difference here. So we'll get, by subtracting u2 minus u1, we'll arrive to 7a plus 3b plus c. We can do the same for u3 and u2. So we'll get 9a plus 5b and plus c, right? And the last one is difference between u4 and u3. So we'll get 37a plus 7b and plus c. All right, so hence we eliminate d, right? Now our goal is to eliminate c, so we're going to take the second difference. Okay, and we will arrive to 12a and plus 2b. So we eliminate c, then we do the same for this two terms, actually difference. So we'll have 18a plus 2b. All right, and the last step, so the bottom line of our process is to get a. That will be the formula soon. So we're taking the difference and we will get just 6a because 2b will be cancelled. All right, so we know that third difference is 6a. And if you know what it equals to, we can figure out. So that will be some number. Okay, there will be some number. Let's say this number is, I don't know. Oh, okay. Yeah, it's not possible because you need to know all the terms. So let's say this is the number, and from here you can figure out a. All right. Once you figure out a, you just go back, and because this is the second difference, right? It was the third difference, and this is the second difference. You can figure out value for b, right? So you can establish value for b because you know a. So in here, this is the first difference. Again, you can figure out c value. And the last, just going up to the top, you know that this is u1. So you can figure out d value. Okay, you understand that in both cases, like no matter you have to deal with linear arithmetic sequence or non-linear, the ways and the steps are pretty the same, except for arithmetic, you end up here, for quadratic, you end up here, and for cubic one, you end up at the bottom line. So it's less likely that on the papers, on exams, you'll be given cubic sequence, but for sure, trust me, for sure you'll be given quadratic, not just simple arithmetic, because arithmetic, everyone can do that. But with quadratic, most students experience difference, like difficulties with difference methods. I hope now you don't. So, hope you enjoyed this video. So, as the last step in our 4 parts dedicated to sequence, there will be like huge review exercise. So I'll just share my idea. So I'll maybe create this video soon, and I'll try to go through several exercises, and the rest part you'll do by your own. So just give the comments what's next topic to create. Maybe it's trigonometry, maybe it will be like something in geometry topic. So write in comments, I will definitely create that. Thanks guys, thanks you've been with me. So thanks for your efforts. I hope you clarify a lot from this topic, and so see ya.